In this video, I am doing a quick review of rationalizing the denominator of a function. To rationalize the denominator simply means we want to remove the radical from the denominator. So let's say we have a function, and that function is 1 over the square root of 2. Well, we do not wish to have a radical in the denominator. Removing that radical is rationalizing the denominator. And the procedure for doing that is to simply multiply the numerator and the denominator by whatever this radical is. So 1 times radical 2 is radical 2. Radical 2 times radical 2 is the square root of 4. And of course, 4 is a perfect square. And so that becomes 2. And we have rationalized the denominator. Let's say we have another function, g of x is equal to 1 over the square root of x. We will multiply the numerator and the denominator by the square root of x. And so we end up with the square root of x over the square root of x squared. And once again, x squared is a perfect square. And so the square root of x squared becomes x. So what you can see, the pattern that is developing here is whatever this radicand is, the number underneath the radical sign, that's what we're going to end up with over here, but without the radical sign. One more example, let's just say we have h of x is equal to 1 over the square root of 3. Well, then we're going to multiply by the square root of 3 over the square root of 3. And so we get the square root of 3 over 3. Another type of function that we need to be able to radicalize the denominator on would be if we have a binomial in the denominator, such as 1 over the square root of x plus 2. In this particular case, we're going to multiply the numerator and the denominator by what is called the conjugate of the square root of x plus 2, which is the square root of x minus 2. So we multiply the numerator and denominator by the square root of x minus 2. When we multiply the numerator, we're simply going to get the square root of x minus 2. And then in the denominator, when we multiply the square root of x times the square root of x, we're going to get the square root of x squared. Then when we multiply the outside terms, I'm using the FOIL method here, we end up with minus 2 square root of x. The inside terms, 2 square root of x, and then minus 4. If you need to, you can watch my quick math video on multiplying polynomials. Now, what's going to happen when we're multiplying conjugates is these two terms will always cancel out. The square root of x squared is simply x, and then we have this minus 4. So over here in the denominator, we simply have x minus 4. And so we no longer have a radical in the denominator. It is rationalized. Okay, let me give you a couple examples for an exercise. Number 1, let's rationalize 3 over the square root of x minus 2. And number 2, let's multiply by 3 over the square root of x minus 2. They look similar, but they are different. Stop the video, do the problem, and then start it up and see how you did. Okay, with the first problem, we simply have one radical. Everything is underneath the single radical sign here. And so we're going to multiply by the square root of x minus 2 over the square root of x minus 2. In the numerator, we end up with 3 times the square root of x minus 2. In the denominator, we're going to end up with the square root of x minus 2 squared. And once again, this then just becomes 3 radical x minus 2 over x minus 2. So just like in the previous examples, whatever this is underneath the radical sign. That's what we're going to end up with over here. In problem number 2, we have a binomial in the denominator. The radical is just over the x, so we have to multiply by the conjugate. Square root of x plus 2 over the square root of x plus 2. And multiplying 3 by both of these, we get 3 square root of x plus 6. And in the denominator, multiplying the conjugates, we're going to end up with x minus 4. So remember, when we multiply the inside terms and the outside terms, they're going to cancel out. So I don't even do that. I simply multiply the square root of x times the square root of x to get x, and negative 2 times positive 2 to get minus 4. All right, I hope this helps.